Hello, my name is David Zhang, and I'm from neuralrobot.ai team. So we are joining the challenge two. The public service works with many laws, policies, and regulations are complex to navigate for client and employees. Our goal is to build an AI system that delivers fast, accurate answers to the proper source citations the user can trust. So let's start. So the we are core of our design is that is on premises the AI and Lego agent. So the system is fully in-house. So no API call, no external dependency. And then with the limited GPU resources, you still can achieve what you need. So our system has four main components: API layer for the interaction for the chat, and then intelligent crawler for collect the official government documents, fine-tuned Llama model, Llama 3 model based, be using the QLoRa 4-bit quantization to optimize for the consumer GPU to better answer the customer for the legal questions, and face vector store to containing 1.96 million documents chunks for the retrieval. So our UI flow is like, so we have a united gateway to answer no matter this legal question or non-legal question, is DOR, is OCR, or is PDF, is whatever you need, right? So and then we have a legal API gateway to handle the request. And then the backend service receive the request and then query our face vector database to retrieve relevant document chunks, and then both the query and receive the context to our fine-tuned the model. And then the model will answer to the customer, and then when reach the first gateway, the response, we will still validate the content is valid, no obvious error, then we return to the customer. So that's how the flow is working. And then our structure is Kubernetes, the lightweight orchestration, most likely the most popular in the industry. And our specialized build a GPU fleet manager that can dynamically assign the work across all the GPU units based on the priority. So it can curate with priority scheduling and monitor GPU's health metrics like temperature, VRAM usage, and computer load. So, and then this is a feature that we develop and very proud of. So you can utilize your the GPU resource as much as possible and as intelligent as smart as possible. So we have the scale, and then for the we have currently we scrolled 16,000 documents ingested, 1.96 million document chunks, which has around 500 tokens each, has been built. And then we have 1,268 PDFs. We have OCR, and it's in the document database already. Of course, the source is from all of the G7 countries. And then our model base is the Llama 3 based, and then we fine-tuned using QLoRa with 4-bit quantization to fit our customer GPUs, which is RTX 3090s we have. And the training is run a distributed script. And then we have everything, every aspect version, feature sets, model checkpoints with short hash rates, prompt templates, and the training configurations. Our model registry track everything, including the GPU type and the dataset versions and the complete training provenance. So we can roll back easily and we don't lose anything. Safety is that we have a strong quality and safety control. We implement multi-layer of protection. First, the prompts is the main spec instructions to the model. Second is our citation validator actively blocks any fabricated legislation. So it verifies every site act and code against our official source database before allowing responses through. And every response automatically includes this is not legal advice disclaimers, and every response includes detailed metadata, the prompt version we use, the hallucination rate score, and the specific warnings and the area of the official source citations. So the user can verify every claim response they got. We have strong security, as we mentioned before. We have every layer in the code control, the file control, file system control, and audit. Everything is in place, and the audit log is in append only. And then we have the model swap, configuration change, gateway access, inference request, metadata, and the entire system operates is behind the air gap boundary. So zero external call, and then that is very, very secure. We have a CI/CD on the pipeline for models. Feature engineering is working, so we can check exactly what's inside each model, and then we after retraining with the QLoRa, every candidate model the model goes through automated benchmark evaluation again, the baseline. So we only promote models that are show the measurable improvement. So no regressions allowed. The registry update is atomic. So everything is working and the rollback as easy as possible. So our testing is 85% code coverage as industry standard, and lots of the our production is Kubernetes rollout, so there's no downtime. And then, as we said before, GPU assignment is smart loading, offloading, and reloading, so it's pretty stable. So our website is live now. It's the neuralrobot.ai. If you go to chat, you can ask any questions, the Lego questions, and you can check the answer yourself, no problem. And then next step is we deliver site validation, GPU fleet manager improve. Or we delivered is citation validator, GPU fleet, face indexed, and the streaming training pipeline, then the test coverage. So next step is the model file hash encryption, and often the offline mirrors for the disaster recovery and the dashboard. So again, so it's 16,000 and the file crowd, the 1.96 million. We have full on-premise fine-tuned based on the Llama 3 model, and the state enforcement, air gap security, distributed GPU fleet, everything is there. So currently we have Canada is over 2,000, UK is over 1,000, US 1,000, UK 5,000, everything is there. And then the performance is 200 milliseconds should be in the retrieval, and the inference is around 2 seconds for 512 tokens. And we can handle around 40 concurrent thread. And every model for the VRAM is around 18 gig. And then totally we have inside our internet is 168 GB. And then the training, regarding our training, we have 36,000 training examples, 48 distributed trainings hours. Checkpoint, you have 3.5 gig LoRa, base model is 13 gig. And then test coverage is the backend is 87, crawler is 82, and then training is around 79. And our GitHub repository is on this link, but it's a private repository now. If you need to take a look, just send us an email. We are open for you. That's pretty much our. We spend a lot of efforts and design everything end to end, and then you can validate on the internet without any problem. And anything, any concern, let us know. And enjoy and have a wonderful day. Hello, my name is David Zhang, and I'm come from neuralrobot.ai team. So we are taking the Challenger 2. The public service works with many laws, policies, and regulations are complex for the navigate to the client and employees. Our goal is to build a smart AI system that delivers fast, accurate answers with proper source citations to the client, so the user can trust. So that's the start. So our core design concept is on premises. So all our resources, no matter is the API gateway, the crawler, the model, the vector database, everything is fully in-house. So there's no security concern, no data governance concern. The system we have, every system normally have the four components: API gateway, for the streaming and the chat, and the crawler for the collected documents, and fine-tuned Llama 3 model based with QLoRa 4-bit quantization, to optimize and then also answer the question accurately, and a fast database vector store to containing nearly 2 million document chunks for retrieval. So when a request comes to our site, we have a unique gateway to chat with the customer for anything. So from the PDF to OCR to mass to any chat. When the gateway chat, this is a legal request, then we have a legal API gateway to go to the legal backend. So the legal backend is when they receive the request, the queries our fast vector store to retrieve relevant document chunks and send both the query and the retrieved context to our fine-tuned models. So the model will return the response, and then every gateway will validate the response is if everything is good, we return to the customer. So from the infrastructure and the GPU scaling, the infrastructure is pretty normal. The Kubernetes is lightweight orchestration, but we build the GPU fleet manager that can smartly assign work across all the GPU resources based on the GPU status and then the task priority. So not only we can load, offload, switch, and then control the GPU resource, and also we monitor the GPU resource like the temperature, VRAM usage, and the compute load. Everything is under control and the smart load smart distributed. So this way we are fully leverage our GPU resource and we can health check for everything. So currently we downloaded 16,000 dominant crowd, and then when we build our vector database is 1.96 million document chunks. Every chunk have 500 tokens around, and then if we have 1,200 over 1,200 PDFs OCR, which have been inputted in the document chunks already. And we, apparently this is from all the G7 official government website. So our training is using the Llama 3 7B as the base, and we use the QLoRa with 4-bit quantization to fit to our GPU resources limitation. So the training can be distributed, and every aspect is versioned. Feature sets, model checkpoints with show hashed, prompt templating, and training configuration. Our model registry check everything, including the GPU type we used and the data set versions, and then to complete the training provenances. So everything is fully under control and easy rollback, and if there's error. And also, we for our every fine-tuned model, we will fully validation. So, so we block any fabricated legislation. It verifies every cited act and code against our official source document before allowing the response through. And every response have that this is not a legal advice disclaimers, and every response includes detailed metadata like prompt versions, hallucination, risk score, the specific warnings, and the area of official source. So everything can build the trust with the customer. We have the strong security concern, security control. So as industry standard, beyond that, we have audit all of the model swaps, configuration changes, query the gateway access, and inference request metadata. So the entire system operates behind an air-gap boundary with zero external API calls, and so everything stays inside the secure perimeter. So for our vision side, we have a full CI/CD pipeline for models. So the feature engineering is versioned, so we can check exactly what went to the model, and if every model, then after training, we have automated benchmark evaluation. So if everything's wrong, anything's wrong, or we don't see any measurable improvements, we don't push the model to the production. And then we can roll back quickly if we need it. So our test is pretty industry standard 85% test coverage. And then the site is open to public now. You can check to anytime. So because this video can only limit 5 minutes, so we don't run a demo here, but you can check anytime. It's running 724 now. So currently we delivered citation validation, GPU fleet manager, bias index in the streaming training pipeline, 85% test coverage whatsoever. Our next target is the hash validation for the model files, offline measures and the disaster dashboards. But if since it's a young premises system, so this is not a low priority. So currently we have everything we mentioned before, over 16,000 documents, nearly 2 million document chunks. Then is fine-tuned Llama 3-based on-premise model, citation enforcement, and air gap security, and we have distributed fleet manager. So currently for Canada, US, UK, Germany, Italy, France, we have every country's documents listed here. And then for performance, we are retrieve 200 milliseconds for the retrieval and around 2 seconds for 512 tokens per inference request. We can handle around 40 concurrent requests. And our VRAM per in the model is around 18 gig. Totally, we have 168 gig VRAM in our system. And then regarding the training, we have 36,000 training examples, 48 hours distributed training. Checkpoint is 3.5 gig LoRa, and then the base model is 13 gigs, 4-bit called the Llama 3B, the Llama 3 7B model, right? So the test coverage is backend 87%, crawler is 82, and training is 79. This is our code repository. Currently, it's private, but if you guys want to take a look, I can open to public to you guys. And then that's all I try to say. I hope you enjoy. Have a wonderful day. Hello, my name is David Zhang. And I'm from neuralrobot.ai team. So currently, we are joining the Challenge 2. The public service works with many laws, policies, and regulations that are complex to navigate for client and employees. Our goal is to build an AI system that delivers fast, accurate answers with proper source citations the user can trust. So let's start. So our core design concept is where everything is fully on premises as the legal system. So no matter is the gateway, is the crawler, is the vector database, and the base model and the fine-tuned model, and the training process, everything is inside of everything is in-house. So there's no security concern, there's no external dependency, and no external data exposure risk and no external dependency. So we have the API and then the crawler. We have the Llama 3 based model fully trained with the QLoRa with 4-bit quantization. And then we have the fast retrieved vector database is nearly 1.96 million document chunks, which is nearly 2 million. And then we have the legal gateway enforcement to make sure our request and response is valid and the correct citation is there. Normally, our normal flow is when a user comes request us, we have the united gateway to request to answer all the users' questions, no matter it's PDF, OCR, or normal chat or legal. So when the legal, it comes to legal chat, and then the legal chat spec handle the legal request. So the legal chat and the API gateway to go to the backend to query our face vector DB to retrieve relevant document chunks and send both the query and the relevant retrieved context to the fine-tuned Llama models. And then when the model response, we are validated by both the gateways to make sure everything is correct before we return to the customer. So our infrastructure is pretty much the Kubernetes, the lightweight orchestration in standard, quite in industry standard. But we build a GPU fleet manager, which is smart, the GPU load distribution, which can dynamically assign work across all of the GPUs we have, and then they handle task queuings with priority scheduling and monitor CPU health, like the temperature, VRAM, and the compute load. And then we can deploy this and manage this very efficiently. Currently, we have over 16,000 documents crawled and ingested, and then again nearly 2 million document chunks. Every chunk have around 500 tokens, and then over 1,000 PDFs we OCR'd, and of course the G7, all of the 7 country sources. And our training is that we model pipelines start with open source Llama 3 7B model because of our RTX 3090, the 24 GB memory, that's the maximum we can hold. But by the way, Llama 3 is very solid quality. So we fine-tuned using QLoRa with 4-bit quantization to fit in the GPU resource, and then the training can be distributed across multiple GPUs, and then we'll version everything, feature sets, model checkpoints with short hash prompt templates, and the training configuration. And our registry to check everything, include the datasets version, complete training provenances, and everything is so it's easy to roll back if needed. Our safety is pretty solid. So we have the citation check in every layer and in every step. We have the safety prompt to check, and then the citation validator actually blocks any fabricated registration. It verifies every site act and the code against our official source database before allowing the response. And then we automatically include this is not a legal advice, a disclaimer, and then we include every metadata, like the prompt version, hallucination risk score, specific warnings, and area of official source citations. So the user can validate and trust our response. The security control is very good, a little beyond the industry standard, and very strong and very enforced. So we have code path monitoring, block all of the suspicious activities. We open only in the audit log, and then of course the most important feature is we are zero external APIs. It's air gapped environment, so it's fully trustable. Everything is stay inside the security parameter. So regarding our training is we are using, we mentioned before, we have the feature set version, and then also one thing I want to address is when we training with QLoRa, every candidate models goes through automated benchmark evaluation against the current baseline. So we know what if there's no measurable improvement, though we don't need to push the new models. So the model registration update is also atomic. So it's whenever we have problem, easy to roll back. Our test coverage is pretty solid. So 85% test coverage, and all the normal check, and in production with Kubernetes, the rollouts, so zero downtime, and then we have a GPU fleet manager can smartly monitor all of the GPU resources during the production time. So I don't want to run the demo now because of the time limitation for the 5 minutes. The site is available and is working 729, so you can validate on the internet, do whatever you want. Everything is ready. So it's neuralrobot.ai/chat. It's it's in the footer of every slide. And then currently we delivered citation validation, GPU fleet, fast index, and streaming training pipeline, 85% test coverage. So next, we only need to make the model files, hash validation, offline measures for disaster recovery, and the dashboard, etc. But it's not in the critical path since it's in premise the system. So in summary, we have over 16,000 official documents, nearly 2 million chunks, and four in-premise the Llama 3-based fine-tuned model, citation enforcement, and air gap security, and the distributed fleet manager. That's the best features we have. We have the documents from different countries. You can see there. Pretty much that's all we have. And our performance is retrieval is under 2,200 milliseconds, and inference are less than 2 seconds, and then 40 concurrent requests around. So VRAM is 18 gig. Total, we have 160 GB VRAM. So regarding our training, we have 36,000 training examples, 48 hours distributed training. Our checkpoint is 3.5 GB LoRa, and the web-based model is 13 GB in the 4-bit. The test coverage backend is 87%, crawler is 82, training is 79, pretty much. GitHub is here, but it's private now. If you need a take a look, I can open so you guys no problem. That's all we try to challenge, and have a nice day, and hope all of the best. Hello, my name is David. I'm coming from the neuralrobot.ai team. So we are participating in the challenge 2 for the law and policy and regulation related. Our goal is to build a system that deliver fast, accurate answers with proper source citations using our AI. The user can trust. So let's start. So our core design concept is fully on-premise AI system. And so everything is in-house, no matter it's the gateway, the crawler, the training, the model, and then the vector database. Everything is inside the firewall and in-house, so there's no security concern. And also under using the consumer level GPUs, you don't need AI center for this and to handle the day-to-day normal work. And then it's doable, and you can check our delivers from our neuralrobot.ai site, and everything's there already. So and then our front end, when they come to the request, they go to the in general gateway, then go to the legal gateway. The legal gateway will go to the first vector store to retrieve related document chunks and send both the query and retrieve context to our fine-tuned Llama models, and then Llama model will return and then validated by each gateway and return to the customer. So our infrastructure pretty industry standard Kubernetes orchestration, and we have a GPU fleet manager can smartly distribute the load based on the task priority, and on the load offload the model, and we using VLM, and then it's fully smart and fully leverage the GPU resource. That's the core concept of our system as well. So far, we downloaded over 16,000 documents. 2 million document chunks are built, and then over 1,000 PDFs OCR, and then across all G7 countries. So our model training is based on Llama 3, 7B as our base. We use QLoRa 4-bit training, and then we distributed fine-tuning there, and we versioned every feature set, prompts, checkpoints. Everything is fully under the version control, so we can easy to roll back. And then the registry, of course, is on-premise, so there's no security concern. Everything's under easy control. And then our safety partner prompts is very, very strict. So we have we validate the prompts, and the site the validator will actively blocks any fabric registration, and it verifies every cited act or code against our official source database before allowing the response through. And all of the response fully include this is not a legal advice, and also every response include detailed metadata. So they no matter the prompt versions, hallucination risk source, the specific warnings, and accurate area of the official document citations. It's easy to validate. And we have the fully implemented secure control as the industry normal standard. And our with the training, and then we have a fully data pipeline for the model training, and then we check everything fully. Every candidate model goes through automated benchmark evaluation against the current baseline. We only prompt models to the measurable improvement and no regression allowed. So our test coverage is pretty industry standard. The moment the site is available, so you can validate anytime you want. And then we have delivered a lot. We only need for the hash validation and then all the next stage, but it's not critical for now. The offline mirrors for disaster recovery, dashboard, etc. And we mentioned this all of the summaries before. And then for Canada, different country, we download lots of files, and our performance is should to be pretty good. And then the training, we have the training hours listed here. And then the test coverage is pretty standard. And our Git repository is available on the website, but it's private now. If you need, I can open to public, and you can take a look. Enjoy. Thank you very much. Bye bye.